Hello, everybody. Salam alaikum to my friends in the region. My name is Adam Semensky. It is my great pleasure to welcome you here in my capacity as the president of KAPSARC. I'm delighted to see so many of you joining us today to explore aspects of the circular carbon economy, or CCE. KAPSARC has partnered with leading international organizations to write a series of reports on carbon management that form the CCE guide. The cornerstone of the CCE guide collaboration has been that each partner has full independence and control over the content of their reports. The CCE webinar series will explore the key results of those studies. I would like to offer a most warm welcome to today's guest, Dolf Gielen from the International Renewable Energy Agency, IRENA. Dolf will discuss the role of non-bio renewables in the circular carbon economy. But first, a short word about KAPSARC. We are an independent nonprofit energy think tank in Saudi Arabia. Our mission is to advance the understanding of energy, economics, and the environment, and act as a catalyst for dialogue on issues of importance to policymakers and the public. This year, the respected University of Pennsylvania think tank survey ranked KAPSARC in the top quartile for energy and resource think tanks globally. For the Saudi G20 presidency, KAPSARC was selected to co-lead the think tank engagement group called the T20. Our Vice President for Research, Dr. Fahad Al-Turki, was appointed to chair the T20, and yesterday the T20 communique was conveyed to the G20. On a separate track, our work on the CCE guide was used extensively by the G20 energy ministers, and the CCE framework was adopted at their September meeting. Now, a little bit about the circular carbon economy. Experts largely agree that the challenge of achieving our climate goals is best met by encouraging all options to manage greenhouse gas emissions. One of the organizing principles of what we call the circular economy is the 3 R's of reduce, reuse, and recycle. The circular carbon economy embraces each of these 3 principles and adds a 4th R for remove. These 4 R's form the basis of carbon management in the circular carbon economy. Reduce the fugitive carbon, recycle and reuse carbon as a valuable resource, and remove carbon and store it. The CCE framework is an integrated and holistic approach to more comprehensive, resilient, and climate-friendly energy systems that support and enable sustainable development. CCE encourages a broad development of technologies associated with managing carbon and other greenhouse gas emissions, and seeks practical solutions that foster economic well-being and improvements in the quality of life for everyone. Dolph's discussion today will focus on the reduce options associated with non-bio renewables. But first, let me introduce Eric Williams. Eric is a senior research fellow at KAPSARC. He has over 20 years of experience as an energy and environmental economist focusing on energy and climate change policy, energy systems analysis, and climate change mitigation and adaptation options. Before joining KAPSARC in 2018, Eric worked as a utility commission economist and was a consultant at the OECD. He's previously worked at the United Nations in academic institutes, think tanks, and in the government. Eric, over to you for the brief introduction. You're on mute, Eric.
Thanks, Adam. So I want to just talk very briefly about circular carbon economy. And as Adam mentioned in his introduction, there's a strong relationship between circular economy and circular carbon economy. And I think it's useful to compare the two to better understand what circular carbon economy is. As Adam mentioned, in circular economy, it's based on the principles of reduce, reuse, and recycle. and circular carbon economy adds a fourth R for remove. And I'll talk a little bit more about what that really means for circular carbon economy in the next slide. So what is the circular economy? It's a framework for sustainable production and consumption, whereas the circular carbon economy is a framework for climate mitigation that values all options. The scope of the circular economy is resource and material flows, while the scope of the circular carbon economy is energy and carbon flows. And the goal of the circular economy is to minimize resource consumption and waste disposal. The goal of circular carbon economy is to manage greenhouse gas emissions, including CO2, toward a balance or a net zero. Next slide. So this is a very stylized view of a circular carbon economy. And in the center, you have the circular economy of material flows. And what drives that circular economy is energy in the form of energy efficiency, renewables, nuclear, hydrocarbon, and bioenergy. And the reduce element of the circular carbon economy is highlighted in red. And those are the options like renewables that are the subject of today's webinar, plus energy efficiency and nuclear that reduce the amount of CO2 that gets generated in the first place. But we can also recycle that CO2 through natural sinks and use the bioenergy. We can remove that CO2 directly through carbon capture and into geologic storage, as well as remove it from the atmosphere with direct air capture to geologic storage. And we can even reuse that CO2 in the form of CO2 to feedstocks or fuels and feed that back into the circular economy. But as I mentioned, today's topic is on reduce, and specifically the role that renewables play in reducing emissions that are generated. And so back to Adam, thanks. You're on mute, Adam.
Touche. You know, renewables, certainly wind and solar costs have come down. It's a terrific, critical aspect of the circular carbon economy. And we're delighted to have Dolph Gillen here today to talk about that. As director of IRENA's Innovation and Technology Center in Bonn since 2011, Dolph oversees the agency's work on advising member countries in energy transitions and renewable energy, technology status and roadmaps, energy planning, costs and markets, and innovation policy frameworks. Before joining IRENA, Dolph was the chief of Energy Efficiency and Policy Unit at the United Nations Industrial Development Organization. From 2002 to 2009, he was a senior energy technology policy analyst at the IEA in Paris. He has a PhD in engineering from Delft University of Technology in the Netherlands. Dolph, we're delighted to have you here today, and over to you for a discussion of the role of non-bio renewables. Thank you.
Yeah, thank you very much, Adam. And thanks very much to KAPSARC and especially also to Eric for the good cooperation in this process. To put it a little bit in context, we have been working with the G20 for some years now. Under the Turkish presidency in 2016, the voluntary toolkit for renewables was established, and then we had the Renewable Action Plan under the Chinese presidency the year later. And then the subsequent presidencies focused on specific angles to look at renewables and how to accelerate that further. So this year, under the Saudi presidency, the circular carbon economy was put center stage. And for renewables, that meant that it's split into two categories. So in a separate webinar, we will talk about the bioenergy, but today I'll talk about all the other renewables. And when we talk about all the others, I mean, it's hydropower in there, it's solar in there, it's wind, it's geothermal, and it's marine. So 5 types of renewable energy. The general trend for renewables is very positive, and the poster child for renewables is very much the power sector. So the share of renewables in total power generation at the moment is around 27–28%. And it has been going up by about a percentage point per year in recent years. And we think that trend will continue into the future, but there is a potential to accelerate that. So with policies in place, we think that the growth will continue around a percentage point a year. What we really need is a growth of around 2 percentage points a year, so that renewables can become the majority of power generation by 2050 worldwide. And there is a different level of progress in different regions. If you look at Europe, for example, this year there'll be around 41% renewables in the generation mix. And if you look more closely at, for example, Germany, in the year to date, it had 52% renewables in the generation mix. So these data, I think, are important because they show that it is indeed possible today to operate power systems with a high share of variable renewables, solar and wind. And that is a new development. Of course, we had already power systems based on hydropower. Now, what is driving that? Policy, of course, is one thing, but another thing is economics. And the economics of renewable power generation have improved dramatically over the last decade. And the most notable number is the cost decline for solar PV. So 80%, 82% cost reduction over the period 2010–2019, and we think that will continue into the future. And that makes that you see now solar PV being offered, countries like Saudi Arabia, like the UAE, for 1.5–2 cents per kilowatt hour. So it has become the cheapest form of electricity. And it has come to a point where new renewables, solar PV and wind, are cheaper than new coal, but even better, it's even cheaper than existing coal. The operating cost of coal plant are higher than the total cost of these new renewables. And these economics, that is the main reason why you see now this rapid uptake. And it will not go away. This is a fundamental innovation that changes the whole paradigm. But the generation side is one thing. Solar PV and wind are variable renewables. So they are not available all the time, and you're not exactly sure when it will be available. A little bit more for solar than for wind, because it's a day and night thing versus a question of when the wind will blow. But you need to deal with that variability. And there are a number of ways to increase flexibility in power systems that enables integration of higher shares of variable renewables. And when I say flexibility, that is defined as the capacity to deal with variability and uncertainty in solar and wind supply, and to minimize curtailment of these generation sources, and to ensure that the supply meets the demand at all times. And so, of course, technology plays an important role. Often the first question we get is from a country is, if we start investing in solar and wind, do we also need batteries? How many batteries do we need? And we say, oh, that's a very good idea, but are you aware that there are 30 types of innovations out there you can deploy to increase flexibility and to allow integration of higher shares? And so, apart from enabling technologies, the market design and the regulations are important. The system operation practices are important, and the business models are important. And so you need innovations in these 4 areas, and often you need to combine innovations in these 4 areas to find solutions for the specific country situation. So this is was an important message to the G20, and we looked at this in great detail. And in fact, now we're having discussions with countries. We've developed a toolkit based on this, and we're talking countries through that toolkit to look what solutions can you deploy in your specific country context. And so a lot of it centers around what we call smart solutions. So a combination of new technologies with digitalization, with a lot more data and a lot more communication in the electricity system. Now, the dialogue around renewables is changing because there is now increasing attention for deep decarbonization. So increasing number of countries are calling for net zero carbon by mid-century. And for that, you need to think beyond the electricity sector. You need to find also solutions for buildings, industry, and transport, what we call the end-use sectors. And that is a new area. We have looked in detail what is possible in these specific sectors, and we found that there is also interesting opportunities to deploy renewables, and especially in industry and in transport that was previously not that clear. So of course there are opportunities to deploy renewables directly, for example solar thermal or biomass feedstocks for synthetic organic materials, but there is especially an interesting opportunity to electrify these sectors, either directly, for example, electric cars, or indirectly by the use of green hydrogen. So where you use renewable electricity to produce hydrogen to, for example, make iron or make ammonia, as is now was recent announcement in Saudi Arabia. So that offers completely new opportunities to decarbonize the economy as a whole. And it means that we're going to need more of this renewable electricity. So it's not only the type of electricity production that changes, but also the way that electricity is deployed and the amount of electricity that is needed in the future. And at the bottom left, you see how we see that decarbonization happen. So what we call the deep decarbonization pathway, DDP, that's a net zero carbon scenario that we launched earlier this year. And the dark blue is the contribution of the renewables. So you see 43%. But you see also the light blue, energy efficiency is very important. And you see electrification, for example, in yellow, the electric vehicles, and in green, the green hydrogen contribution. So together, this is about 90% of what we see as solutions. So these are really the three pillars of decarbonization in our view: renewable, efficiency, and electrification of end use. And in terms of electrification, today electricity accounts for around 20% of final energy use. That will increase somewhat in a business as usual scenario to around 30%, but we think there's a potential to accelerate that significantly up to nearly 50% electricity share in final energy use by 2050. So, and to achieve that, we need, of course, a lot more electric equipment. We need especially more electric vehicles. We see electric cars already growing significantly, but we think also that in the commercial vehicle sector, there are interesting opportunities for electrification. And that is changing because there's a rapid improvement in battery performance, and the cost of batteries continue to fall rapidly. And in the building sector, heat pumps are, for example, an example for an electrification strategy where we think there is a potential to increase nearly tenfold from today's level to 2050. So hydrogen has worldwide seen a huge growth in attention in recent years. And for us, green hydrogen produced from renewable power has become a very important topic. We are currently, again, closely looking at electrolyzers, which is one of the two key components for such a strategy. You need efficient, low-cost electrolyzers, and there are a lot of developments that point in that direction. The other thing you need is really cheap renewable electricity, 2-3 cents max per kilowatt hour. So it's that combination that allows this option to come into play. And we are working in that in quite a number of dialogues. The newest one will be in the COP26 preparations, the Race to Zero high-level event later this month. Now, so we see a technical potential to make such a transition happen. We also think that it's economically feasible, but we need investments. We need for the period to 2030 around 60 trillion investments, around 4.5 trillion per year. And for the period to 2050, we need 110 trillion in investments. And the energy investments are quite different from what we've seen in energy investments to date. There is still some investments in fossil fuel supply, but it's a minority share in the total energy sector investments. The majority goes into efficiency, renewable power, and enabling grids and electrification. So that's what you see in the breakdown for 110 trillion on the right here. And in absolute terms, that's a growth compared to the reference case from around 95 trillion to 110 trillion. So it's not such a significant increase, but a very different allocation of investments that makes the difference. Now, in terms of macroeconomic effects, so that is something which, of course, is also of great interest, especially as we're talking currently these post-COVID stimulus packages. we find for the longer term a potential to increase GDP by around 2.4% through this energy transformation. And we find also a potential to increase a significant number of jobs. So you see that the total number of jobs in renewables would grow from around 12 million today to more than 40 million. So nearly a fourfold increase. So through this transition, you can also achieve important economic objectives, and that is very important in today's discussion. So we looked at what could a stimulus package look like. Our recommendation for the next 3 years is a stimulus package that has an energy component of around 2 trillion per year. And such a stimulus package could create, by 2023, around 5.5 million additional jobs. We're today not on that pathway. There will be a need to strengthen the energy transition component of these stimulus packages. And for example, in Europe, that is currently part of the discussion of the Green Deal package. The impact of COVID on renewables investments or on renewable sector in general has been not very significant. In fact, we see in many countries that the share of renewables in power generation this year has gone up. I mentioned the example of Europe, but it's also the case in other parts of the world. And if you look at the global market, for example, solar PV sales this year will increase compared to previous year, and also offshore wind will increase this year compared to previous year. So the renewables have kept up very well through this crisis, but of course the numbers are somewhat lower than what everybody expected at the beginning of the year, when there was an expectation for really a record year, and now it's just a good year. But we expect that this growth will pick up again as we come, as we emerge from this crisis in the coming years. And for example, you see that there is strong attention for investments in electromobility as part of the stimulus package, and you see that that sector is really picking up at the moment. So recommendations for G20, align post-COVID stimulus package with the clean energy objectives. Second, as the 2030 national determined contributions to the Paris Agreement are being revised, this is an important year ahead of COP26, and also as now more and more countries are looking into net zero 2050, we need concrete strategies and concrete plans how to achieve that. So developing clear targets, not only high-level objectives, but practical targets is really important. And of course, we need also the enabling frameworks and regulations to support such transitions. I mentioned the issue of investments. We need to increase the investments. Public sector finance alone will not be enough. We need to increase a leverage. So public finance as a way to mobilize also more private sector capital for investments in energy transition. We need to have the human skills and capacity for this energy transition. There's a significant effort also needed to strengthen that further. And finally, we will need continued innovation to also create the solutions at scale for these hard to decarbonize sectors, for example, in energy intensive industry and in parts of the transport sector. So that concludes my remarks. Thank you very much.
Thank you very much, Dolf. One of the things that I think is worth mentioning is the T20 communique that was delivered yesterday to the G20 included a number of recommendations, several, let me just mention a couple of them that fit in with your discussion, Dolf. Build back better through COVID-19 sustainable stimulus packages that target clean energy and climate goals, supporting carbon management technologies. The T20 focused a bit more on negative emission technologies like direct air capture and so on. But they also mentioned trying to coordinate a rapid ramp up in global hydrogen markets that would certainly fit in with the renewables approach. I mean, there are a lot of what I would say synergies that I think are available here. We did have, we had a number of questions come in, and we'll be delighted to take questions through the Q&A channel. Dolf, one of the first ones was, what's the land footprint of renewables relative to other possible fuel alternatives? You know, could you compare solar, wind, and you know, this question actually came up when we did our nuclear power webinar. Nuclear power has a fairly small footprint for delivering energy. Do you have a comment on that?
I mean, it varies a lot, and it depends also a little bit on how you count. So I would say for solar PV, it's not significant.
Right.
For wind, for onshore wind, it depends a little bit how you count. Because you have, I think, around 4 megawatt per square kilometer, but of course you don't use the full space. So if you have agricultural land, then you have the wind turbines at the edges of the field.
So you have dual use.
The field.
Right. One of the interesting things, Dolf, I actually, when the question got asked on the nuclear panel, I looked it up, and I suspect that these things are coming down as wind turbines get bigger and efficient, more efficient. Same thing with solar panels. You probably take up less space. I did see that just recently China put into service a 2.2 gigawatt solar field, which is just kind of amazing. And I guess it depends on the country. Saudi Arabia has plenty of space to put in solar, just as an example, and that may not be the case in some smaller countries or countries that are more urbanized. But I suspect that it could become an issue over time as you developed more of the solar and wind resources. But I think what you just said, Dolf, is it's not a limitation at this point. Is that fair?
Yeah, and what you see in countries that have indeed space limitations, for example, is a trend to offshore wind.
Right.
And a more recent development is a trend to floating offshore wind. So, I mean, granted, Japan, for example, has space problems, but this floating offshore wind opens up whole new potentials, and that is a general trend you see with renewables. So where there is a constraint, then you see innovation and new solutions emerge.
Eric, over to you. Do you have a question for Dolph?
Yeah, I mean, just to follow up on that theme, I read recently that Singapore has announced or is considering a deal with Australia for a transmission line that would enable solar energy in Australia to be transmitted to Singapore. And I know that people are at least thinking of the idea of a similar line that would connect Saudi Arabia or the GCC region to India to do a similar thing and to maybe take advantage of maybe some of time differences in terms of solar energy availability in Saudi Arabia versus demand in India. Do you think that this sort of trend will continue?
Well, let's say that there is a lot of activity for better interconnection. You mentioned Singapore, for example. They are already importing hydropower from Laos, so the existing grid. And for example, in Northeast Asia, there's also a lot of study going on, for example, in connecting the Gobi wind and solar potential in Mongolia to Korea or even to Japan. So technically, these things are feasible. But of course, there are also political dimensions to it. And perhaps today the political dimension is more of an issue than the technical one. So we have to see how that develops in the future.
Dolph, you actually answered one of the other questions was, are there geopolitical issues? And I guess the answer to that is yes. If the power has to cross borders, then you are going to run into that. How would you rate the progress being made and the ultimate power output levels from solar rooftop versus concentrated solar power? Where do you think the growth is going to be?
Well, I mean, rooftop PV accounts for 30 or 40% of the PV that is installed worldwide. And total PV installations worldwide is 600-700 gigawatt. And the latest numbers I saw for CSP is somewhere between 5 and 10. So that means that at the moment we have rooftop PV, which is 20, 30 times, 40 times more than CSP. Of course, CSP has certain attractive characteristics. It has an interesting storage potential, but that is also a dimension that is changing a little bit, because you see more that battery costs are coming down rapidly. And for example, here in Germany, where I live, the majority of new solar PV rooftop systems are equipped with batteries. But that is because electricity here costs around 35 US cents per kilowatt hour.
It's a lot.
So of course, it's a quite different price from other parts of the world. And that makes the economics for that option. But for example, also in Australia, you see rapid uptake now of batteries. So it's likely that both will play an important role. But I think that the role is a bit different for these two options. One is a large-scale utility solution.
Right.
The other is a decentralized household scale type of solution. You
mentioned storage associated with solar. Molten salt, I guess, with concentrated solar, batteries with rooftop, and sort of typical land installations. Do you think that there's a role for hydrogen as a storage medium for solar installations?
Well, if you purely look at as hydrogen as having the same function as a battery, it has a few disadvantages. And the key one is that the cycle efficiency is around 50%, while it's 95% for a battery. So for overnight storage, hydrogen seems an unlikely solution. But for example, if you have a strong seasonality in your renewable supply, say PV in Europe, so you have a lot of sunshine in summer, you have no sunshine or virtually no production from solar PV in winter. Then you could imagine that such a storage option could play a role. And also, of course, it could become interesting because you can ship hydrogen or hydrogen commodities easier than electricity. So if you can, say, produce ammonia with solar PV in Saudi Arabia and ship that to the markets, that offers an opportunity to tap into renewables potentials that would be more difficult if you didn't have that option. So right. I think that is the way how to think about this hydrogen.
There is just for our listeners today, NEOM, the new sort of living area in Saudi Arabia in the northwest part of the kingdom, has very strong both solar and wind resources, and there is a proposal underway from NEOM to invest nearly $5 billion in a green hydrogen project, with NEOM partnering with Aqua Power and Air Liquide in producing green hydrogen and ammonia for the kingdom. Saudi Aramco also shipped some blue hydrogen ammonia to Japan recently, so there's some activity going on there as well. Dolph, one of the questions which I think is interesting is there are what analysts call the hard to decarbonize industries, steel, cement, aluminum, shipping, aviation, and petrochemicals. The question was, is there something that, like in the cement industry, that might be compatible with renewable power to try to deal with those hard to decarbonize areas?
With cement, you talk about one of the most difficult sectors from a renewables perspective. Right. The reason being that the majority of emissions in this sector are process emissions. So they're not
coming from the making of the cement itself, not the fuel being combusted.
Yeah. So naturally, you can't solve that issue with renewables. You have to think about new cement types. You have to think of different concrete types. You have to think about CCS.
Thank you for the candid answer, Dolph. I think one of the ideas that I guess is around on cement is the concept of curing cement with carbon dioxide that can make the cement stronger and also hold the carbon dioxide for long periods of time. So it's an interesting, again, I think this comes back to the idea that the circular carbon economy tries to address, which is there are probably different solutions for different industries, different countries, and that kind of thing. Are there any, Eric, I feel like I'm monopolizing here, and why don't you, I'm sure you've got another question. Let me just ask Dolph a quick one. What are we doing with transmission of power? That would certainly make renewables easier, direct current transmission, any kind of breakthroughs going on here that would make renewables more effective in their use?
Well, I think that there has been a lot of activity in this area in China in recent years. So they've built quite a number of ultra high voltage DC lines from the resources in the west to the centers of demand in the east. So 2,000-3,000 kilometer DC power lines. So, and the progress has been to move to lines with even higher voltages and higher capacities. So now we're talking single lines which have maybe 15 gigawatts or so of capacity. So that is significant. It's technically proven, and that could be more widely deployed. But again, the problem is not so much the technology, but for example, if you look in Europe, and also in the United States, I mean, the planning around these lines, that's where the issue is. And that is an area where we need to spend more time if we really want to move in this direction in the coming years.
All right. You know, Dolph, I'm kind of laughing because I was thinking about the geopolitical issue, and I know from my experiences in the United States, there are geopolitical issues between states and transmission lines that have actually been a serious issue for building good new transmission lines in the U.S. Eric, back to you.
Yeah, I was just going to say, I'm also currently living in Germany, and I've been talking with people here, and my understanding is that there's been plans to build a north to south transmission line to be able to take advantage of offshore wind in the North Sea, for example, and then supply that to Bavaria, where you have the biggest demand. But again, the actual siting and building out of that infrastructure is difficult politically to get done, even in a country as wealthy and is able to do these things as Germany. So yeah, I think that is a big challenge. But one question that I have for Dolph, in your work at IRENA and really digging in deep on the technology, are there any technologies in the renewable space that are on the horizon that you think may be disruptive? Anything in the pipeline that we should really be aware of that could make a significant impact beyond just the continued improvement and evolution in cost reductions of PV and so on?
Well, I think this development of floating wind, floating offshore wind, which is just starting now, will have a significant impact in quite a few countries, because it allows to move to deep waters, and there's a lot of countries which don't have shallow waters. So I think it really changes. It can change the narrative in countries such as, for example, Japan, but also the potential for Europe is very significant of that option. And then so as you say, I mean, there is an incremental improvement in many of the renewables technologies. That continues to make significant differences. I mean, we talk about PV as a mature technology, but if I look at the watts per panel number, it's amazing how quickly that continues to increase in time. If you look at the trends now towards building integrated PV, that opens up a completely new opportunity for solar. So even these mature technologies continue to innovate very rapidly.
Yeah, the growth in technology and investment in new technology is going to be critical. And I couldn't agree with you more on that. One of the things, transmission isn't always required. I mean, one of the advantages that solar PV has certainly is its distributed power and has certain advantages associated with that. So that's, again, I think a reason why moving forward on as many possible solutions as possible is probably good for everybody. Let the scientists and engineers work on the best possible solutions. Dolph, one of the questions was, and I guess it goes back to batteries and storage and that kind of thing, but what technologies look like they're gaining the most in terms of dealing with the variability and volatility in renewable energy power production?
Yes, so batteries is certainly one of them, but as said, I mean, we see it as part of a much broader flexibility package. And for example, where there is a significant potential that has not yet been deployed widely is demand side response and demand side management. So, for example, if you talk about Middle East context, cooling is very important.
Right.
If you can store more cold, then that opens up an enormous flexibility potential and opens up much more opportunities to integrate solar PV. So it's really these type of options we need to look at more closely and then deploy more widely.
That sounds like a good plan. One of the other comments that came out, Dolph, and it would be interesting to hear your view on this is, are there opportunities for microgrids in electricity to help take advantage of non-bio renewables?
Well, so we see two trends. First of all, microgrids for places where there is currently an access issue. We see that growing. We see also that renewables microgrids are increasingly replacing diesel microgrids because the economics are favorable. For example, for mining operations or remote villages in Alaska or Siberia, and you name it. And a third category is microgrids integrated into a big grid as an energy security measure. If there are issues of a blackout, then the microgrid allows you to continue operating. So all three are going quite strong.
Right, trying to integrate, I guess, is basically the answer. Well, we're coming up we've actually gone a little bit over our 45 minutes, but Dolph, we've really enjoyed having the opportunity for you to discuss this with us. On behalf of KAPSARC, I'd like to thank the International Renewable Energy Agency and Dolph Gielan for being with us today, and for Eric Williams, who helped coordinate the CCE guide. It's available out there for anybody who would like to have a look at the individual reports from all of our partners. It's on cceguide.org, and there's lots of very interesting reports and other resources that are available there. So Dolph, once again, thank you very much to you and to IRENA for the very thoughtful presentation on non-bio renewables. And we look forward to, I think, maybe having you back to talk about the bio renewables work that you've done as well. And that should be very interesting. And I hope to see you again soon. Thank you, everybody. Bye.